Hello, welcome to Maths is Not a Mystery. We're looking at angles today, and there are a few things that you probably already know about angles. If you've watched our earlier video about angles in polygons, you should know that angles in triangles always add up to 180 degrees. And you should know that angles in quadrilaterals always add up to 360 degrees. They're things that will come into some of your angles questions from time to time, even though this particular video is about a different kind of principle with angles. What we're looking at today is angles on parallel lines and angles at a point. We're going to quickly start with the angles at a point. You know that a circle is 360 degrees, I'm quite sure. If you have a whole bunch of angles joining together at a central point, then they will add up to 360 degrees. And then a lot of questions that you'll get, they will tell you some of the angles. So you could potentially get an angle that maybe got a right angle on it, and then another angle here that's 30 degrees, and another one here that's 80 degrees. And then they might say, what is that? And all you've got to do is do your 90 plus 30 plus 80 and see what's left to make it up to 360. So they're quite straightforward. A quick word of warning with all of these things: never ever in an exam measure these angles with a protractor. They will always be drawn wrong. That's so that you don't actually measure. You've got to work it out. Now, another piece of information that you ought to really know is that when angles join together at a straight line, then this angle here is 180 degrees. Okay, if we could have just opened that up, spun it round, that's 180 degrees. Obviously, it carries on all the way around again to 360 degrees. So they're basic pieces of information that we would hope that you already know. What you've got to do with the next step, though, is you need to be looking at these ideas of angles on parallel lines. Let me show you exactly what it is we're talking about. They have names. And if we start with one that's actually not on parallel lines, it doesn't need to be parallel lines. If we have two lines that cross each other, this angle and this angle here are called vertically opposite. All right, they're not always vertical, but they are opposite each other. And the thing that is important about these is that they're equal. They're going to be the same. If this is 40 degrees, then this is 40 degrees. There is no question about it at all. Okay, whenever there's a straightforward cross like that, those two angles are the same as each other. Obviously, it probably goes without saying that this angle and this angle would be the same as each other as well. You could even work out what they were, because all the way around is 360 degrees. So far we've got 40 plus 40, which is 80. 360 minus 80 equals 280. And that's shared between those two angles. Half of 280 is 140. So each of those other two angles would be 140 degrees. So you can work out quite a lot from just being told maybe one angle there. Obviously, if these were at an absolute cross like that, and that was a right angle, it's obvious that that's also a right angle, and so are those other two there. So vertically opposite angles are equal to each other. Now, if we draw a couple more parallel lines and we put another one through it, what we can look at next are these two angles here. And these two angles are called alternate angles. All right, and you can probably also see with these that they're also equal. In each little group here, you've got a pair of big angles and a pair of small angles, and the same applies at this level. And in each case, the two small angles on this top line are the same size as the two small angles on the bottom line. Same goes for the two large angles. So they're called alternate angles. They're on separate lines. That's on the top line, that's on the bottom line, but they share a sort of common position to make their sizes exactly the same. All right, let's take a look at the next one. There are 4 of these things all together. So we've looked at 2 so far, vertically opposite and alternate. Now the next ones, draw the same thing out again. This time we're going to look at this angle and this angle. And they're in the same place, aren't they? They're in exactly the same place, and they're called corresponding angles. And once again, they're equal. You can see they are, can't you? These 2 are the same as each other, and they would be the same as those 2 that I've just put dots next to. And then obviously there's a pair of small angles on each junction as well, and they'd be the same as each other. Not the same as this one, but the same as each other. So once again, another set of equals. So we've got vertically opposite that are equal, alternate that are equal, corresponding that are equal. The final group are not equal. What's left? Well, let's take a look. This angle and this angle. They're called supplementary angles. And they add up to 180 degrees. That's a big one, that's a small one. You could kind of lift this small one here and transfer it up here so that it would be where I'm just going to put that little bit there. That is the same as that, and together they go onto that straight line, which makes them 180 degrees. So supplementary angles equal 180 degrees. They add up to 180 degrees. So in the questions that you're going to get in various exams around angles, you're going to sometimes be given a single angle and be asked to find or to say what the size is of another angle in this group. Okay, and you've got to use one of those 4 rules. You've got to decide what the rule might be, and then when you give your answer, what you should do is you should give the size of the angle, and then you should explain what the rule is that you've used. So for example here, if we say this is 120 degrees and what is the size of angle X, then you would write down as your answer for full marks that angle X is 120 degrees because corresponding angles are equal. You would explain what rule you've used. Okay, if this one here was 40 degrees and that was angle Y, then you would say that angle Y equals 140 degrees because supplementary angles add up to 180. Okay, that's the way you do it. So you give them a number and you'd give them a reason. Okay, and sometimes there could be more than one choice of reason. Sometimes you can look at these and think, oh, well, am I going to call it corresponding, or am I going to say that it's something like maybe a vertically opposite one, because I'm using it from a different area that I've already looked at from some other information they've given me on the page. As long as you give a valid reason, you'll get your mark. We're going to stop there. There are more examples in the book, in the Maths is Not a Mystery book about angles, so feel free to take a look at that, try the system out, work through the worked examples, and we'll see you again soon on Maths is Not a Mystery. Goodbye.